Welcome back to Tell Me More Stories Told This podcast, where we like to take the things you see every day and uncover all the extraordinary stories behind them. Today we'll be diving into something you probably use a dozen times a day without a second thought. That's right, we're talking about taps.
Most people don't give them a second thought, but when you really start to look into it, there's a fascinating world of engineering and history, and maybe even a little bit of culture behind the simple tap.
I love it. It's like we're going on a plumbing-themed adventure, so where do we even start?
Well, let's start with just the word tap. Here in the US, we say faucet, but in lots of other places, it's tap.
Really? I always just assumed it was a faucet. Why the difference?
It's just one of those quirks about the English language, and it gets even weirder. Plumbers here in the US will sometimes call outdoor taps a spigot, and if the tap goes through a foundation sill, it's called a silcock.
Wow. So many names for the same thing. Next time I talk to a plumber, I'll have to show off my tap vocabulary. Okay, but let's get practical here. What about the little hot and cold indicators? Have you ever noticed how sometimes they're just in the wrong place?
Oh, yeah, for sure. Some places will even use C for hot and F for cold, which can be really confusing. It all comes back to using Celsius or Fahrenheit for the temperature.
That makes sense. So the abbreviations are kind of like time travelers from a different system of measurement. Speaking of traveling through time, let's rewind a bit. Remember the old setups with separate hot and cold taps? Trying to get the right temperature must have been a nightmare.
Oh, yeah, I can just imagine trying to wash my face with that setup. You'd be stuck between a freezing cold stream and a burning hot stream. Luckily, in 1880, Thomas Campbell invented the mixer tap.
The mixer tap.
Yeah, he found a way to mix the hot and cold water together so you could control the temperature from one stream. It was a pretty revolutionary idea at the time.
It's amazing how much of a difference one little invention can make.
Right.
But how does the mixer tap actually work? Is there some kind of little water wizard in there constantly adjusting the temperature?
Well, not a wizard, but it is pretty clever. It's all thanks to pressure balancing and thermostatic mixing valves. These valves are constantly monitoring the pressure and temperature of the hot and cold water. So, like if someone flushes the toilet while you're in the shower, the valves automatically adjust the mix so you don't get scalded.
So it's like having a tiny robot in your tap, making sure you always have the perfect temperature.
Yeah.
Okay, and what about the different types of handles and mechanisms? Some taps turn really easily with just a quarter turn, but others feel like you're fighting with them.
That's all down to the valve mechanism inside. The old-school globe valve uses a rubber washer to stop the flow. It's a reliable design, but the washer can wear out over time and start to leak.
Ah,
Then there's the gate valve. It uses a metal wedge to cut off the water. It's smoother than the globe valve, but it doesn't always seal as well.
so it's a trade-off between a good seal and smooth operation.
Exactly. And then for those really smooth quarter-turn taps you mentioned, those use something called a ball valve. It has a ball with a hole in it that aligns with the water inlets when you turn it. So a simple 90-degree turn will completely shut off the water.
Wow, it's incredible how much engineering goes into something we use so effortlessly.
Mhm.
Now, before we go any further, I want to remind our listeners that if you're enjoying this deep dive, be sure to hit that subscribe button so you don't miss any future episodes. We've got a whole world of fascinating topics waiting to be explored. All right, so we've talked about the taps we see every day in our homes, but are there other less common types of taps out there?
Oh, yeah, absolutely. Like in places where hygiene is really important, like hospitals and labs, they often use foot-controlled valve.
Foot controlled.
Yeah, so people can turn the water on and off without using their hands.
Oh, wow, I never thought of that. That makes sense, though, especially in a hospital.
Mhm.
What other kinds of specialized taps are there?
Well, you've probably seen the touchless infrared sensor taps in modern restrooms. You just wave your hand under the sensor and the water starts flowing.
It's like magic.
Right. And then there are laminar flow devices.
Laminar flow devices. What are those for?
They're really specialized. They're designed to create a perfectly smooth stream of water with no breaks or interruptions. They're really important in places like research labs or for certain medical procedures where even the smallest amount of contamination could be disastrous.
So it's like a super precise, super clean water delivery system.
Mm-hmm.
I'm starting to realize that there's a lot more to taps than I ever imagined.
For sure. And we haven't even gotten into the materials they're made from. Did you know that the move from metal to ceramic and plastic components has led to some big advancements in tap technology?
Oh, that's a good point. I remember my grandmother's old tap was this big, heavy metal thing, but mine is much lighter and smoother.
Yeah, you got a good eye. That difference is probably because of the materials. Older taps were mostly made of metal, but modern ones often use ceramic and plastic parts.
So it's like the tap world is evolving and using new materials to get better and better.
Exactly. For example, ceramic surfaces have incredibly low friction. So ceramic taps are super durable and they're much less likely to leak. Plus, they're resistant to corrosion and mineral buildup, which can be a problem with older metal taps.
That makes a lot of sense. I've spent way too much time trying to clean mineral deposits off old faucets.
Yeah, and modern plastics are surprisingly strong and resistant to corrosion too, but they're mostly used in tap components because they're lightweight and inexpensive.
So it's like each material has its own advantages, and tap manufacturers are combining them to make the best possible product.
Yeah, it's like a chef combining different ingredients to make a delicious meal.
Okay, so we've talked about all this cool new technology and stuff, but we can't forget about safety.
Right. You're absolutely right. Taps are supposed to give us clean water, but there's
Right.
always a chance of contamination. That's why we have things like backflow preventers and vacuum breakers.
Backflow preventers, what are those?
Well, imagine you have a garden hose and it's submerged in a bucket of soapy water. If the water pressure suddenly drops, that soapy water could get sucked back into the main water supply, and that could contaminate the whole system. Backflow preventers are designed to stop that from happening. They act like a barrier and prevent any unwanted substances from getting into our drinking water.
That's kind of scary, but it's good to know that we have these safeguards in place. So backflow preventers are like the unsung heroes of the plumbing world.
You could say that.
You know, it's amazing how something as simple as a tap can play such a big role in keeping us healthy.
Absolutely.
Well, we've covered a lot of ground today, but we'll have to leave it there for now. Be sure to join us for part 2 of our deep dive into the world of taps, where we'll explore the fascinating physics behind how they actually work. And we'll take an even deeper look at the evolution of tap materials.
Sounds good.
Until next time, keep those taps flowing and those minds curious.
Welcome back to Tell Me More Stories Told Us podcast. We're diving back into the world of taps.
You know, after our last conversation, I'm really starting to see taps in a new light. It's incredible how much thought and engineering goes into these things.
Absolutely. And today we're going to get even deeper. We're going to look at the physics of how taps actually work. Have you ever noticed how the sound of water flowing from a tap changes depending on how much you open it?
Now that you mention it, yeah. Sometimes it's a gentle whoosh, and other times it's almost like a hissing sound.
That's because the flow of water through a tap is a great example of something called choked flow. Basically, the valve inside the tap restricts the flow of water. So the amount of water that can pass through changes depending on how open the valve is.
So it's like when you blow air through a straw. If you make the opening smaller, it makes a higher pitched sound.
Exactly. And here's the really interesting part. When the water flows through that narrow opening, the pressure drops really quickly. This is because of something called the Venturi effect. And that pressure drop can actually cause the water to boil.
Wait, what? Boil? But the water's not hot.
I know it sounds crazy, but it's true. The pressure drop lowers the boiling point of the water. So even at room temperature, the water can vaporize and form tiny bubbles as it passes through the valve. And when those bubbles collapse outside the valve, that's what creates that hissing sound.
Wow, that's mind-blowing. It's like there's a tiny science experiment happening every time I turn on the tap.
Exactly. And that's just one example of the amazing physics at work in a tap. Now let's talk a little more about the materials that taps are made from.
Okay, yeah, we touched on this before, but I'm really curious about how we went from those old heavy metal taps to the lighter ones we have today.
Well, it's a pretty fascinating story. You're right, older taps were mostly made of metals like brass or chrome. And while they were durable, they also had some downsides.
Like what? Did they rust easily?
Yeah, corrosion was a big problem, especially in areas with hard water. Mineral deposits would build up and clog the tap, and that could lead to leaks. Plus, metal taps were heavy, which could make them hard to install, and they could even put stress on the sink over time.
So how did they solve those problems?
Well, they started using new materials, especially ceramics. Ceramics are incredibly durable, and they have very low friction, which makes them perfect for tap components. Plus, they're resistant to corrosion and mineral buildup.
So ceramic taps were a big step forward.
Exactly. They were lighter, smoother to operate, and more reliable. And they required less maintenance.
It's amazing how much of a difference the materials can make. And what about plastic? I see a lot of modern taps with plastic parts.
Yeah, modern plastics are surprisingly strong and corrosion resistant, so they're good for certain tap components. Plus, they're lightweight and inexpensive.
So it seems like tap manufacturers are using a mix of materials to get the best of all worlds.
Exactly. It's all about finding the right material for the job.
And that's led to some pretty cool innovations. Like, what about those smart taps I've been hearing about?
Oh, yeah. Smart taps are pretty amazing. They use sensors and digital controls to give you a more personalized experience. Like, imagine a tap that automatically dispenses the exact amount of water you need at your preferred temperature.
Wow, that's pretty futuristic.
Yeah, it's like having a personal water butler. But smart taps are also good for the environment. They can help you conserve water by tracking your usage and detecting leaks.
That's great. So it's not just about convenience, it's about sustainability too.
Exactly. And it's important to remember that taps play a vital role in our health and well-being.
Absolutely. We need clean water for drinking, cooking, cleaning. It's essential for our health.
Exactly. And that's why it's so important to take care of our taps. Even the most high-tech taps need regular maintenance to keep them working properly. Things like cleaning aerators, checking for leaks, and replacing worn-out washers can make a big difference.
So it's like anything else. A little bit of preventative maintenance can save you a lot of trouble down the road.
Exactly.
So before we move on, is there anything else our listeners should know about the world of taps?
Well, it's important to remember that tap designs and regulations can vary a lot depending on where you are in the world.
Well, that makes sense. So a tap in the US might be different from a tap in Europe or Asia.
Exactly. For example, in some countries, it's common to have separate taps for hot and cold water, while in others, mixer taps are the standard. And the placement of the hot and cold handles can be different too, which can be confusing if you're traveling.
So there's a whole world of tap etiquette to learn.
You could say that.
We'll have to say that for another episode. But for now, we're going to wrap up this part of our deep dive. Be sure to join us for part 3, where we'll explore the cultural significance of taps. And we'll look at some of the latest trends in sustainable tap design.
Sounds good.
Until then, keep those taps flowing and those minds curious. Welcome back to Tell Me More Stories Told Us podcast for the final part of our deep dive into taps. It's amazing how much we've uncovered about this simple object. We've gone from engineering to materials to even physics. But now I'm wondering, are taps more than just functional objects? Do they have a place in history or culture?
Well, they actually do. Taps have a surprisingly rich cultural history. They've shown up in art and literature and even mythology. For example, in ancient Rome, they had these elaborate public fountains with ornate taps. And those fountains weren't just about providing water. They were also status symbols representing wealth and power.
It's fascinating to think that something as practical as a tap could be a status symbol. So there's an aesthetic element to them as well as a functional one.
Exactly. And different cultures have different beliefs and traditions associated with taps and water. In some Asian cultures, flowing water is seen as a symbol of purity and cleansing.
Wow, it's incredible how something as simple as a tap can have such deep cultural meaning. It really makes you realize that every object has a story to tell. Speaking of stories, what about the story of taps and sustainability? With all the concern about water conservation these days, are taps changing to meet the challenge?
Definitely. Tap manufacturers are really starting to prioritize water efficiency in their designs. We're seeing a lot more low-flow taps that use things like aerators and flow restrictors to reduce water consumption.
So I can still have a good, strong shower without wasting a ton of water.
Absolutely. And there are other innovations too, like sensor-activated taps. They automatically turn off when you're not using them, so you don't have to worry about those accidental drips.
It's like they have a mind of their own. As we wrap up our deep dive into the world of taps, is there any final piece of wisdom you'd like to leave our listeners with?
I think the most important thing is to be mindful of how much water we're using. Even simple things like turning off the tap while you brush your teeth can make a big difference.
It's all about being aware of our impact on the environment, even in those little everyday moments. Well, that brings us to the end of our journey into the world of taps. I have to say I've gained a whole new appreciation for this everyday object.
Me too. It's been a fascinating exploration.
And I hope our listeners have enjoyed it as well. So next time you turn on a tap, take a moment to think about the ingenuity and history behind it. And remember, even the most ordinary things can have extraordinary stories. Thanks for joining us on Tell Me More Stories Told Us podcast. Until next time, keep those minds curious.